Okay guys, I'm going for record time today. Let's keep this one short. This is a really easy concept. We're looking at families of polynomial equations. And so by the end of this lesson, you understand what is meant by that term, a polynomial family. And you can find specific members of that polynomial family when you're given sufficient information about that family. All right, so let's just jump right into it. What is a family of functions? So what you see here are 4 different functions graphed, and these are a family of functions. Every single one of these are they have 1, 2 turning points, okay? So 1, 2. So if you remember back to turning points, the degree of the function is likely plus 1. So these do have opposite end behavior. If this is green up here, then it's green down here. So it's an odd polynomial with 2 turning points. So degree 3 polynomials. So they share some things, and they share the same amount of turning points. They share the same degree of the function. They all have opposite end behavior. But you will notice that they also all have the exact same intercepts. And that is really important. Not only do they have the same intercepts, the order at those intercepts is the same. These are all order 1, okay? It's pass through, pass through, pass through. So this is a family of polynomial functions, and here are the equations that correspond. So the red, green, purple, and black. And really what you'll notice is the equations are all the exact same. The only thing that's different is the a value. So in this first one here, we have where a, that's a funky looking a, is equal to 1, and here we have where a is equal to -1, and here we have where a is equal to 1/2, and here we have where a is equal to +3. So this is our, just a is 1, our not untransformed, because there are transformations applied to that function. This is the one with the vertical reflection. This is a vertical compression. This is a vertical stretch, and this is the one that has neither vertical reflection, compression, or stretch. They all belong to the exact same family. Okay, so determine the family of cubic functions that have intercepts at -3 and 3 plus or minus √2. So if you did watch the second part of the last lesson, then this will be a kind of review. You've already seen how to handle this situation. If you did not, remember that we are going to, and because we're writing, it doesn't specify standard or factored form. We are going to write it in factored form. So we need to start out by saying, okay, well, we have one factor, but what's important is that k value. And I should say a or k. Sometimes in the textbook you'll see it called a. Sometimes you could see it called k. I often use a. Right, these are our a values, but in fact I think in the examples I'm going to use k, because sometimes when I do a it looks like a9. So we're going to have k. If the solution is x minus 3, the factor is x plus 3. If the solution, so this is 2 solutions, this is 3 plus √2 and 3 minus √2. Oop, that's not a 2. So I'm going to have x. Now, the 3's are both positive. That's why I'm putting minus 3 plus √2 and x minus 3 minus √2. Okay, so I've written them in factored form. So from here, I got to clean this up. We've got x plus 3, and then I'm going to distribute the negatives here, or yeah, both of them. So I've got x minus 3 minus √2. I've got x minus 3 plus √2, because I've got a negative times a negative. And I mean, I could leave it like this, but I'm going to say we need to clean these up a little more. This one, fine, but let's do our expanding. So I'm going to do x times x, x times -3, x times positive square root of 2. So x times x is x squared. X times -3 is -3x. X times positive √2 is √2x. And then I've got to do the same with my -3 terms. So I've got -3 times x is -3x. -3 times -3 is +9. -3 times positive √2 is, sorry, -3 √2. Oop. 3 root 2. And then last but not least, we've got to distribute these negative root 2's. So I have negative root 2 times positive x is minus root 2x. Negative root 2 times negative 3 is positive 3 root 2. Negative times a positive is a negative. Root 2 times root 2 is 2. And again, if you didn't watch the last lesson, the extra one, then you'll see that some funky stuff happen, or some nice things happen here, I should say, not even funky. X plus 3. I had a positive root 2x, and I have a negative root 2x. I have a negative 3 root 2, and I have a positive 3 root 2. So those are gone. The messy ones are gone. Then I've got a negative 3x and another negative 3x. So that's negative 6x. First off, this is here. So we've got x squared minus 6x. And then I have positive 9 minus 2, which is positive 7. Okay, so therefore, determine the family. So the family of cubic functions, which is also how I knew these were order 1, because it's a cubic. It can only have up to 3 roots. The family, I'm just going to say, can be defined as or represented as f at x is equal to k. We don't know what k is, so we just leave it. X plus 3, x squared minus 6x plus 7. Okay, one more example. So now a family of cubic functions has x-intercepts at -1, +1, and 2. Find the member of that family that passes through the point 340. So remember, points are x, y. So first thing we're going to do is start out in our factored form. So we don't know what k is. We know we have a factor at x minus 1, so that's going to be x plus 1. We know we have a factor at +1, so that's x minus 1. We know we have a factor at +2, so that's x minus 2. And now we want to know, and I should actually say that x, y, in this course, we should be considering it as x and f at x to replace y with our function value. So that when we do substitute in, we can see that when x is 3, we have a function value, when we sub in that value of x, of 40. So now I'm replacing f at x with 40. I'm replacing x with 3, 3 plus 1, 3 minus 1, 3 minus 2. And I want to know what value of k needs to be true for this function that is the family of functions, but for it to specifically pass through that point. So I clean up my factors. 3 plus 1 is 4. 3 minus 1 is 2. 3 minus 2 is 1. 4 times 2 is 8. Times 1 is just 8. So we have 40 equals 8k. And then we divide by 8, and we get 5 is equal to k. So we could say, therefore, the member that passes through (340) is f at x is equal to 5, bracket x plus 1, x minus 1, x minus 2. Pretty easy stuff compared to our last lesson. For practice, page 119, again, you see that EOP, so that's every other problem. And I would go even further and say that, like, however many you need. If number 1 is, A through L, then maybe you just do the last couple and check your understanding. Or if you're like, I have no idea what I'm doing, then maybe you should do all of them. So number 1 through 5, as you see necessary, numbers 8, 10, 19, and 20. And that is it for this lesson. Sub 10 minutes, guys. I think this is a record for me. Have a good day.